Hello, welcome. And today, what we are going to do is try to finish up the Type Plus about the equality, the equal type comparison to make the whole things work and clean up adding the remaining things. So that I can release it. And so you can see over here, I have 200 something, 280 almost file changes. And so that will be a lot of stuff. And that's why it was a little bit delayed. I was planning to release this, 2-3 days ago. But the more I dig into it, the more things I need to add and clean up and so on. But anyway, before I get started, this is a just code stream. But before I get started, to avoid being say this is a clickbait, I want to show you what I got over here now about the equal check. So what happened is this. So in the past, I was doing, this is the last version, the latest, the previous version, I should say, of the equal check in Type Plus. There's still missing some case. And this is the new one. And so to first give you an overview or high level description of what it is the equality check in TypeScript is hard because the underlying mechanism that what TypeScript provide is a one direction thing. So you would able to do say extends, right? But extends will only compared it in one way. So basically checking, is the, say over here, G is a superset of A, right? And not the vice versa. So if you want to really check it, you will need to do something like this. I'll get into this a little bit. Actually, let me say like this, say type equal, right? And then A, B. Right, so one common mechanism people do is using this, what they call is a identity check. So it was doing it like this, and then if these are all good, then this, this then return true or false. Right. Some library out there are doing it like this. For example, Typefast was doing it like this, and also some other libraries. This is not complete because there are cases that it miss. So just to show you again the test that I have done. Right. So here are the tests. Right over here. So you can see that there's a lot of things over here. I was doing a permutation of everything, just make sure that things are fine. So, well, let's just give you some high level overview of what they have, right? Compare true for primitive type, compare false against each other, and then the 4 special types. They are never, void, unknown, and any, and then do some comparison between them. And then also another thing is the literal type versus the container or the widened type, especially with Boolean. So that is also a problem because the Boolean, when you compare the Boolean is actually a union of true and false type. Right, so if you're not careful, just comparing, implementing this, some of this will fail. And then the same thing for number, but the number and string, those are relatively okay in this case. And then there are also things like checking for the subset, and then union, disjoint, overlap, and so on. So you can see there's a lot of different cases. So let me just show you, go here. All right, so this is the implementation. So if I comment this out and put that guy over here, right? So you can see that there are some of them over here on the right hand side. This fails over here, some of the case, right? It fell in the union case. This is also a union case, and so on. And then also the special types all fail over here, right? So so that's why just that is not sufficient. Right. There is a recently there is a change, to on this to make it a little bit better, right? Say is adding this over here, right? So this you can see that it help in one or two cases. You can see the union type is now working. The error is gone, so you can see here this error is gone, but it still fail cases like this, right? So even this is not sufficient. So that's the identity way to do equality check. Another way is to using this mechanism. So let me put this to the bottom. No. To the bottom. Okay, there you go. Right, so, and then let's say just, well, then else. Right. I think I did a miss in presentation just now. Let me undo this. Make sure that I'm not sharing the wrong information, right? So it really should be like this, because in TypePress, I have this mechanism so that you can do some type programming directly inside the type, like this. So there's some drawbacks, some pros and cons between doing it this way versus using the extends equal true and all that. But I will probably save that for another video. So over here, because I'm doing this over here, I really should be saying returning then and else. And so now you can see that the override case for the special types is actually working. So the only thing that doesn't work are the more complex things like this, right? And then also the intersection type, right? This still doesn't work, right? So it's pretty close, but not sufficient. Okay. So the other case, the other way, I should say, to do this is using this check, right? So what happened is if you were originally the simpler form, let me just also cover that, is you can say A extends B and then B extends A, doing it like that, right? So, but you can see down here, this will fail in many cases. One reason is because of the distributed nature of the condition type when you're doing it like this. And to get around it is to put them inside a tuple. Make them a comparing at a triple level, wrap it inside a tuple. So doing it like this helps a little bit. You can see the number of errors goes down, but there are still a lot of cases that doesn't work, especially say things like this over the special types, and then also things like this that doesn't work because this is doing a wrap of a wrap, and then it doesn't work. Let's put it this way. So this is a more compact form of the one that you just saw, right? Compare this and that. This is essentially doing the same thing, but this is just a more compact and nicer way to do it. And to note, one thing to note that is this check wasn't working in TypeScript 4.9. right? It works in 5.0, right? It's a bug that just fixed recently in 5.0. So that's that. And but if for just using that as a comparison equality check is still not working, like say over here with the any, it doesn't work well, right? So that's why this is still not sufficient, right? And those these two forms or three forms, depends how you count it, are the main mechanism you can find out there for a lot of the type libraries. So at the end, with this one, which do a lot of check for the never type and the any type, this finally get everything to pass. So you can see that over here on the right hand side, everything passes on here. So if you're interested later on when I push this up to the TypePress repo, feel free to check out the test. And I might still missing some cases. Can never say never, right? Because this is a complicated work. But you know, feel free to check it out and see if you find anything. Let me know. Open a ticket in the TypePress, a issue in the TypePress, and then we can take a look into it. And of course, over here, if there is some way to simplify this, yeah, also let me know. So what this does is essentially doing some special casing, checking explicitly for never and for any. So there are ways to do that. And without, well, the code over here is pretty simple. You can see that here, this test, I'm just using one of the variants. No, I just show you to do the check. And for never, for the never case, this is sufficient. And I have added a whole bunch of tests just for that, you know, and it works fine. Right, of course, again, you know, I could make some mistakes, and that's still, you know, if you find anything, let me know. And so what's over here is check that if both of them are never, then it shortcut the logic, because comparing the never to never is true, so it goes to the then case. And if one of them is never but the other is not, then we can explicitly saying that, okay, that doesn't compare, and return false, right? So, and then the same thing for this any case. Right, so that's what this nesting does. I want to simplify this, but haven't think of a nice way to do it yet. So if you have any suggestion, again, let me know. And then the other check over here is checking for object and function. So if it is not object, right? So this is an and cross to say that if both of these are true, right, then we will be doing this. If not, we'll be doing the simplified form. So what happens is when they are not object, meaning they are really primitive types, you know, string, numbers, symbols, and so on. For those cases, I find just this basic check is sufficient. So that's why I shortcut it over here. And of course, and also if it's not, if I'm not doing this, you know, some of those cases goes into here and it mess up the algorithm. So that's why I do the check over here. And then the next case is that inside when A and B are both object, they are also functions. And for functions, there are something special, like the inferring type, the return type, and all that, and also function overloads. So we need to carve out some specific logic for that. So that's what this is for. So when it is function overload, it turns out this will work. right? If they are functions, I should say. If they are just function, this will just work fine, and calling this is not, it's fine. But when it is not, then this check doesn't work well for the pure object, the non-function variant. And so for that, need to go to the identity way to do the check. And in here, that's also one more thing is this property types. So this property types is a very simple type like this. And what it does, and actually I can add this to shortcut it, but I'll do that later in a moment. So this could shortcut it to make it a little bit faster. In other libraries, this is sometimes it's called simplified. In Typefast, it's called simplified, and maybe in other place it's called prettify. Because what happened is this on the if you look at traders and so on, people saying that, oh, the nice things about this is it allows you to make the code cleaner, make the type cleaner, and as in here. Let me see, where's the example? Do I even have an example for that? Actually, I don't have an example for that. Well, let me just do it right now. Right, so let me just say type R equals to properties, and then say A equals 1 and B equals to 2, like that, right? So when you're doing program TypeScript and doing return type and mixing the type together, sometimes you would end up with type like this. There's a lot of end case. Say, for example, one of the things I do nowadays is create some context type. So like say context A, which will be A and then with some function foo and this return void. And then a type context B, and then with a B, and then say bar void like this, right? And then the context C will be equals to context A and context B. The reason I'm doing it like this is because when you think about OO or think about SRP, single responsibility principle. When you're writing some code, you can provide some interface, right? But then how it is being consumed is also can be or should be, in my opinion, controlled by the code that you're writing. So that's why I'm doing it like this, and then compose the context together using the intersection. Like that, right? I said it wrong again. It should be intersection. So that's why I'm doing the code like this. But when you do the code like this, the type, if you write it in the function, it will become expand out, become like this, and make it pretty hard to read, right? So this type, it will combine, merge them together, right? Become a single type again, like this. So it looks much cleaner and easier to consume, right? Especially when you're writing the code and looking at the IDE, looking at some return type of a function, and it have this, and then it just get too long that the TypeScript truncates the type, so that it make it harder for you to understand or to read exactly what's the type that it get returned, right? So that's why libraries like Typefast, they added this type to try to make it a little bit cleaner to read, which is nice. However, what I found out is that, well, this doesn't really work well when the type that you're talking about or trying to use involve function signature. Again, the function is a subset of, I should say function signatures is a subset of object. So this is an object. So when you do the using this prettify, you can see that over here, it will end up with just that, right? The function signature is being removed. So that's why I think the name, the prettified or simplified, is actually misnamed. It shouldn't be like that. And so over here, I'm calling them calling this type as just properties. I bring it up in the Twitters, and thanks people up there, Barrett and Titan, and also Johnny, to help response and saying, agreeing that, properties or props should be the name for this type. And yeah, that's that. So thank you. And so this is that. And here, now back to this case, right? For the identity check, if I just doing this, and so let me go back to the test, put it back over here, right? If I remove this, so you can see that there are some tests that are failing, namely is exactly that, right? The end case, the intersection types, that doesn't work, right? So I have to extract this. The reason for this is because when you're doing the identity check, it's really checking that identity, the actual type of the actual type A and type B, comparing them. So since these two types, they combine one versus the separate, the intersect one, is they are technically different types. So that's why this check will fail for those cases. Right. So because of that, I'm using this properties type to combine any intersection type together into a single type, so that this identity check will be correct, right? And then, as actually when I'm describing this, is a little bit backwards, because what I actually did is I start with this, and then I find out, okay, this still doesn't work for the intersection type. So then I add this. Then after I add this, the function overloads doesn't work. So that's why then I have to add this in. So at the end, this code works, right? That's what I end up with. It still is long. Again, if any of you look at this and find out, okay, there should be a way to improve this, then feel free to let me know, and we can work together and try to simplify this a little bit. But the logic should be clear. It's not really too hard, right? It's just the key is spend the time to actually adding all these test cases. And again, I could still miss something. So if there's something that you find over here, let me know, and take a look at that. All right, so that concludes the equality part. And so now I can go back to the quote-unquote just code part of the stream to just try to finish this up. As you can see that in order to write this, I have to write this is never type, is any type, is object, is function, and so on. Right, so that gets me into all these types that I'm adding. And that's basically why I got delayed the release a little bit. So because as I'm doing this, I want to do a complete job instead of just adding one function and leave it as is. And so what these are is try to complete these for all the primitive types, the undefined, null, number, Boolean functions, and so on. Right, there's still some more that I need to work on. And the logic of this, in the new release, you will see that each of them will have these 4 functions or 4 types, right? And they are named similarly. And so what they do is, this is a what I call the filter, right, or the pass-through types. So what it does is check, this accept anything except unknowns. And so it checks if it is a function. If it is, then it passes through, right? It go to the then case and just returning that. And if not, it will be never. So it's kind of work like a filter. And the not case, the same thing. It's just that it is the other way around. So one thing to note that they are really the not case of each other. It's not to say that kind of like a Boolean true or false thing, right? You think about this as a set. Right? When it is a function, then this will be true, or this will be passed through. When it is the other case, is anything but function, right? It's not just Boolean, it's a set, right? So that's that. So we have this, and then we have the Boolean variants of this. So that's what that is. And this are not named correctly. So, and the Copilot, this is awesome. Now I don't have to, right? I can rely on the Copilot to do this, and most of the time we do the right thing. You always still need to check it, but most of the time it is good, and just some simple checking should be sufficient. So let's see if this is a function, is a pass-through, right? So I want to add a function over here to say that the basic type, although you won't use it, but for example, I want to add that in, right? And then those are special type. So I want to say some normal things, like say 1 is that. Oh, well, actually in this case, maybe let's say a equal 1. And also have a union case. Is the union case now? Union case. Yeah, so the union case, this is for function, this is something special. I think, well, since this stream is, well, the reason I'm doing this stream is for sharing knowledge. Is let me just jump into it and talk about this as we go. So for other types, so far I have found this is working pretty uniformly, but for the function it's a little bit special. So over here, when I'm doing the union check, right, this is true. So you can see that over here. Let me make it a little bit bigger, right? This is true. It's able to extract it and do the comparison and so on, right? So this is fine. Well, since I have that, let me just go ahead and add that in, because that is important, right? Doing that, and then this will become that. Okay, so that's fine. For the else case, so this should be fine. That's that. And then now over here, this is the interesting part, right? Okay. So let me see, is function. And this is why even though it looks silly that I have to repeat it for all of this test case. So you can see over here, the way I implement it is I implement it once and then just reuse it by passing different default values, right? So this is a Boolean. This is still a pass-through, but just swap the order. Right? This is the same thing, and in Boolean, right? So supposedly, it should be straightforward. However, in this case, over here, you can see that this is actually returning a Boolean. And the reason is because this is when it is a union, it distributed out. So there it would distribute to check that if this part is a function, the answer is yes. And then if this part is a function, the answer is no. Right. So because of that, the type that get returned is actually Boolean. Right, so this is that, and that is the Boolean is also one of the reasons that I spend a lot of time to work on, because as mentioned, or as you might know, Boolean is a union type of true and false, right? So because of that, unlike other literal type like string and numbers, it behaves a little bit differently when you try to do comparisons. And a lot of the E-types library out there doing the check, it doesn't really check for this, and it could lead to problems. So what you see over here, this true and false set, they are checking for the literal type. Right. Too big. Second, go back over here. Right, so these, they are checked separately. So you can see that there are all different kind of tests to do that. So using this one as an example, you can see that the Boolean type, it will do the pass-through if it is Boolean, but when it's just true or false, it will not. It will filter it out. And then the same thing for the Boolean, the true type and false type, right? If it is false, then it's good. But I missed the type again, return never. And here I should say T in is, let's say, because they are similar enough, or true. Returns never. Second, I mess up my things. So never. And then this will be Boolean, should be never, and true should be never. Okay. So you can see that it's doing the exact check. And since, as I found out, I forgot to add this, now I have to go back to everyone to do a double check. Is false. Yep, I'm missing this. This should be return false if it is Boolean or that. So this is false. This is false. So now that is good. And then it's not Boolean. Yes, this does check that. And then this one I forgot to add. So this return true. It should be. Is not false. And then this will be true. Right. As when you work, write so many stuff over here, sometimes when you write this, you can your mind can start, just skim over it and bypass it. So a lot of times I have to slow down to think about, are this right? Because the 0 and 1 check is, to me, is the hardest thing, one of the hardest thing in programming. You could easily mess it up, right? So this is true. Is Boolean not false? It's true, right? Is true not false? Is also true. So that's that, right? So is not false, and then it's not true. So this would be true if Boolean or false is not true, and then false, and this should be true. Okay, and for the is true, this will be false if Boolean or false, and then so this should be false is true, and then this should be false. Okay, so this also return t if t is true to make it consistent. Did I? No. This is wrong. This is true because this is a Boolean or predicate check, right? This return true false. I shouldn't say the other way, where it's not a pass through. Right. So doing it like this, it should be like that. So the next one, true, false, literal. Yes, that looks good. By the way, if any of you is reading this, if you see any issue, spot anything, let me know in the chat. So now this, let me also add this type in. Got it. Never special type. Yep, I didn't check. Passing t if this is false or true, so that is good. Not right, so this case it will be equal, and then this will be Boolean, and this will be true. Return true, Boolean or true, passing the t. Okay, so that's right. The last thing, so return tree. I can copy this instead. Doing this if Boolean or false, right? No false. No, I typed the same thing again. No true type, and then this is false, right? Although yes, you might think that this is tedious, but trust me, there are cases that you will find bugs when you are doing this seemingly stupid and repetitive work. So that's why, you know, and also this is open source project, right? So I do keep it try to keep a very high standard, you know, make sure that all the cases are passed. You know, I cover all the cases that I can think of because it can be used by many people, right? Although, you know, so far, you know, TypePress is relatively popular a little bit. I hope more people will be using it, and but for that, meaning I have to make it more useful. Right, so yep, so I think I'm almost done. So these true type, so return true. No, this is wrong. Return t if t is true. Return never if Boolean or false. Never. Oh, false. Don't need this. Don't need that. Hold on a second. Oh, never. Okay. Yep. All right. That's adding those types. Okay, where am I? Right. Oh, okay. So I was talking about the Boolean types and then the type checking functionality. So yeah, speaking of this, this is some new. This is also a new mechanism in TypePress. In the past, in previous versions, I have this is type function that I use to do the equality check, and then also you have this is never, and also this true and false, right? But what I find out, you know, as I'm doing this is there are some limitations on this, And especially, well, for this one, it's actually the same. You know, the mechanism do the comparison is the same. It's doing this is equal and all that. And the difference is that now the signature is different, so that the way to use it is a lot more, a lot nicer. So let me give you an example. So say over here, see if this one can reproduce it. So in the past, when I need to compare this, I would say true, Boolean type, Boolean. Okay, so this will still pass. Right, the original one, this one, I add the true or false here to say that if this comparison should be compared as a true or false case, and also if they are not the same. Say for example, this is string. This is where you can see that it failed, right? So it gives you the immediate feedback. However, one of the problem is when you're doing it like this, I have a harder time to figure out what is the result of this. And actually now I see that you can actually still kind of see it over here, right? But you know, having it like this wasn't to my liking when I'm doing this. So that's why in the new code, I'm adding this so that it separated true and false over here. And then the first one, also this type will be returned. So cons y, right? This will be returned to the actual type. And then, well, let me give you a better example, because this is, say, omit A equal 1, B equal 2, and let's omit A. And then I wanted to, let's say, failed it. True. Right. Like that. Right. So over here, so you can see that even in this case, it's able to resolve it, and I can see the result right away. But more complex types over here like this is still showing the expression, so to speak, the type expression. And I don't know, okay, what does it actually resolve to, right? And this is the same thing for the is type equal, right? So for completeness, I'm expecting them to be the same. And then I put this in over here, and then it doesn't, right? But then I don't have any way to figure out, okay, what does this exactly resolve to? And what I have to do is I have to extract it out and put it in another type so that I can see, oh, this resolve to be with type 2, right? So that slow me down, right? And so in the new code over here, I can, as you see, I can get the, only if I can type, get the value like this, right? This is still showing the type, but then I can do the type R equals the type of Y and get the result. Right, so it's a little bit better. I wish there is a way for me to just resolve the type out so I can quickly see it. I haven't found a way yet. The reason is this resolution, right, going from this omit expression to this type seems to happen only at this type of, and I can't do it like this. That doesn't work. That doesn't work. It's a invalid syntax. So yeah, I haven't figured out how to do it. If any of you can think of a way, let me know. That will make our life a little bit easier. But so far, this is what I have, and is a little bit better, you know. So that's that. So this is the new type comparison. And one more thing is I'm going to differentiate these, the is type, and also there is the assert type for this, and this is doing the assertion, right? Doing assert subject is T. Over here, the is type. This is doing the type guard. Right, this is really a type guard, and this can be used in at runtime. Right, so this can be used at runtime. While this one, it really should be only used during test, right? Because you can see that this is actually faking the values, right? This what you pass in true or false, right? Like over here to get the result, but then I just cast it to the type S just for the inspection. The code is the value and the type is completely different, right? So this really shouldn't be used in runtime. It's only used for testing. So I'm not sure if the name type is good or not. Maybe test type, but that's a little bit verbose, right? So I'm calling it type right now. If there are other names, I might also bring this up in Twitter and see if I can get a suggestion on this naming. And so that is that, right? So this is also new in the new version of Type Plus. Okay, so that's enough talking. And so now let's try to finish this. Import non-function type, which is fine. What do you get here? Okay, good enough. Okay. Close this, and then the same thing over here, right? Not function type, right? So should this be never? I actually can't remember. Not function type. Oh, not function. Where's the test? I don't have the test yet. Yes, I don't have the test yet. That's why. So let's figure that out. Not function type. Okay. Not function type. If this return this, for sure it will return never. Right? If t is a function, so this will be never. Right? So that's good. And then this, right, probably will also be never. I think that is the current behavior. Yep. So that match our expectation, right? And since the implementation is just flipping the side, is likely correct. But you know, as you just saw in the Boolean case, you know, it might, or in the union case, that might not be true, right? So but since it is not a function type, so this should be never. But it is not. Hold on a second. It's spread. Okay, yeah. Yes, that is true. Right, so it's the same thing because it is distributive, it's separated. So during the union, it will first check, is this not a function, which is false, right? And then if this is not, which is true. So because of this is true, then it get passed down. Right, so this got distributed out like that. Like that. And this is a little bit hard to read. So let's do the check. Type R equals to type of R. What did I get over here? Yeah, it's the same thing, right? We got the same thing back. Although over here, yeah, this also do one resolution. So it seems like it does do some cleanup over here. But over here, you can see, let's get this whole thing out, right? The whole thing is like this. So you can see that it's actually separate. It distributed is having this one case, having this case, and having this case. Or not. Say this is an OR case. Let me see. Just make sure that we... What kind of syntax is this? Ooh. Comma? Why there's a comma? So this is an OR case. Supposedly, is that right? That's how I read it. So this union that, union this, but what is this? Comma? Oh no. You bet me. This is this is A. A is this guy, and then comma. This is B. Yeah, this is this guy, and this is this guy. So this does got resolved, still resolved to that. It's just a pass-through, right? It's just a pass-through. So yep. So that's why it is. It doesn't do addition resolve. That's what it resolves to. Okay, so is this correct? Is this meeting our expectation? The code is simple, right? It's just the flip side of the function type, but is it what we want? So let's think about it. It is not a function type, right? So this, one of them is not a function type because it is true, it's passed through. And my gut feeling is, yes, this is fine. The way that we're using this, right? If this type is ever being used, is when we want to make sure that, say, we cannot call this type, right? Because if it is not function type, meaning there is something inside a union, if it is a union, that it is not callable, essentially, right? And this is not callable, right? So that's why this should return quote unquote true and do the pass through and return this thing, right? Return the whole union. So yeah, so I think this is the correct behavior. Okay, so I think that's good. Returns never, so now back to here. Return never is function signature, and then this will pass through, right? Return T for special type equal and that. the not case is always takes the most time to write because I have to repeat this equal. Aha, I did that again, stupid. Over here, and then copy this, paste it over here. There's some mismatch. So cleaning this, it should be a string. Okay, now that should be fine. So this will show that it should pass through, and then if is function overload, this should be false. Yep, this should be false. This should be return error because all of them are callable, right? When it contains only function signatures. So this is never should be just that. And then intersection, right? So intersection should be never, as expected, because it is callable. So never. And then can override. And so if it is not if it is this, that, and then just get a simple case object. Hold on. Oh, this should be 1. 1 because they are true. They are not function type. Okay. So there you go. So that take care of another one. So we have 3. We are missing one more, which is not function. Oh, we probably know what it is. Not function. So return false if t is a function, so this should be false. Return false if it's just signature, so this should be false. And then this should be true. What am I doing? True. This should be true. And then it's not a function. This should be Boolean. That's the case that I was talking about. The description is wrong over here. Returns Boolean if it's a union of function. And I should better describe. That doesn't help because the union type distributed it. So well, let me just be precise. Void returns true while A1 return false. But the result is true and false, which single arrow. Okay, I'm fine with that. Okay, so yeah, like that. So this is Boolean. This should be the same logic. It's still a Boolean. Right, so return is just that this return false, this return true. So it becomes false and true and Boolean. Okay, we will fix the actual test later. Just finish this. If it is function overload, yes, it should return false. Return also false because yeah, it's callable. And then the override. Right, so can override, that will be the same. Okay, so now let's go ahead and fix this. So this should be true. And then this 2 should be false. And then this is not a function, is not a function. So this return this, and then this all return true. And to have a normal case, right, having it like that. All right, I'm getting a little bit scared. The reason I keeping this, not normally I really should just keep checking, committing the changes, because I could lose all this. Especially I know that the VS Code sometimes will screw up, and I have it happen twice to me that it mess up my Git changes, and it remove all my changes. So I really should add that, check it in, but I was trying to figure out what I need to add. The string type, no, I'm getting too scared. And in this case, I really want to branch, create a new branch. So what should I call it? Equality. Sure. Doesn't really matter. I can change that later, but I want to commit it first. If not, it will be pretty bad. I will kill myself. Okay. So what do I have so far? So let's use one of the things over here. So the undefined, I have it already. Now I have it already. Number type, yes. So just double check the number types over here. I have only 2 of them. Okay, let's add them in. Is number is true. This is false. Okay, that's great. Like that. Right. Then export type, not number type. Alright, true, false, number else. Okay, that looks good. Export type is not number. Then true, then false. Nope, this should be else. This should be then. Yeah. Yesterday, the Copilot in one of the test case, it switched these over to get then and false, and I spent like 30 minutes before I found out, oh, this is actually not right. It should be true, else, false. So yeah, it's a good tool, but don't trust it wholeheartedly yet. Is not a number, that's true. This is true. This is true. Doing that. All right. So that's that thing. Yeah. So one thing I'm still wondering about is the naming of these. Right, especially it comes to the types with literal type like numbers and string, and also Boolean is too, kind of. But for Boolean, you can do the true type, false type, so it's kind of justified. You can I can pretend that's working as expected. But for number and string, this really could be a problem, because when people think about number type, they would naturally think about both number and number literals, right? And the same thing for string, right? String and string literal, we will consider as a number. But for these types, is specifically to do a strict test, so it will exclude the literal types. So that's why this is false over here. But the naming of this might be a little bit confusing. Maybe I'm still debating. Maybe this will add a straight over there, and then have one that is loosen up and accept literal types. Not 100% sure yet what should be done. And of course, any change like this will be a breaking change. So I want to think a little bit more about it. But this is what I get so far, or right now. So we'll see. Yeah. So that's that. And so now let's add the test in, shall we? It's tedious, yes. It's boring, might be, but it's needed. Not number type. Maybe the code GPT can help me to do this, but yeah, I don't know. If T is number, although it's kind of sound a little bit stupid. Yeah. Return never if T is number literal. So let's say negative. Let's say never. -1, remove this. Let's do 3 of them, right? The typical case for that. Never for special type or other types. It take care of these already, so this looks good. Never is a union, which is fine. Is it fine? Is it fine? Is it fine? Yes, it is fine. Number. So this would be something debatable. Oh, I do have this already here. And it's good to also have this guy. So I do have that already. Anything intersection. This is a primitive type, so intersection also doesn't matter. It will just resolve to never. The thing is this guy. When it is a union of number and number literals, what does it mean, right? Well, for one is that's not much I can do, because that will resolve to number. Well, I should say type x equals to number or 1. This is automatically widened to number, right? So since it is number type, this is number, that is true, right? That's not much I can do. So that answer my question. Should I say number or n? Okay, I'm fine with both. in this case because it's literal type, right? Same thing over here because this really just one thing. Well, for consistency, let's do that, and this is T. Let's change this to T. All right, so that's that. And then just number, let's put a 0 over there. Make sure that there's this case. Let's change this one more time. Not number, right? So this now return never. And so this is never, take this out. And then this will return T equals like that. This will be negative, this will be 1.1. Okay, so this will return T. So equals, same thing over here, copy, paste. So this should be, yeah, same thing, T equal. I did that again. No, I don't want that. On this. If that, do I have to, this is the number, right? So number is that. This is that. This is string. This is function is okay. And then this is that. Okay, so this will also return T. So equals. And then this, since it go back to number, it will become never as expected. And then this can override. Number is 2. This would be 1. This would be 1, 1, 1, 1. Okay. The reason I was doing this check, this is something interesting to share. Because the conditional type, later on I probably will need to make another videos about it. A lot of times when you think about conditional type, say R equals to well, f of t, right, equals to t, say extends number and then true or false, for example, right? I used to think that yes, this is a ternary statement or if statement or the conditional type, but in fact it is not really just a conditional statement or ternary because of the distributed nature of it. And so there's a case that it will say, for example, when it's distributed, then this become a Boolean, right? Not just true or false, or not just either true or false. It could be one of it, both of them combined together. And it also could be never when it was distributed. In other words, it also is a special case, or I think it's the same case. So when you think of condition, or at least for me now, I'm thinking of conditional type, I need to keep reminding myself it is not just a ternary operation, and that is one of the reasons why I'm adding all this, right? So that it is easier to understand. Although speaking of that, there are still some limitation for these types, because these types does not do the narrowing for you. So that makes the application of these types smaller, because say for example, use the number type for as an example, right? So let's say again type full of t, and if t extends number, then over here, right, then t is a number. Well, actually, let's say any array, right? Then over here, TypeScript knows that this, after that, this is an array. Before that, this is unknown, right? If I don't do that, if I comment this out, right, doing this, I get nothing, right? I get nothing because TypeScript does not know what this type is. This is unknown. It's styled as unknown. But when you do the conditional type over here, now in the true case, we know that it is an array, or TypeScript know. But on the other side, it is still unknown. Right, so you need to you are able to drill down and narrow the type through the conditional type. But when you're using this, the TypeScript currently does not have a syntax to indicate that this is a a conditional type replacement, that I can say, oh, when you go through this, then the t will be a number. Right? There's no way to describe that. So if you need to do the narrowing, right, then these types you can't use. You can't really use it, unfortunately. Although this is accurate. So the actual application on this is still not sure. For my use case over here, doing the equality check and doing other stuff, this will still be useful for some basic checking. Right, or at least I can do something like this, right? So although it is a little bit more tedious, right? So number type, right? If that is the case, the true, then over here I know t is number, right? And then to get the same thing back, I can say t, yes, I have to do it again. Then t, I have the number type over here. And then let's say false. And then the other case and will be t is not number. Then I can do something else over here, right? False. Right, so this line, this conditional type is extra, but it is needed to get that type inference back so that you can use it. But still the benefit is using this, it allows you to confidently know that it will be number and not number literal. Of course, again, as I mentioned, this number versus number literal for this case might be a little bit not very useful, but for exact type checking, this is useful, and also for other check, especially for array versus tuple, and that will be pretty useful. So that's that. So this is the number type. Now again, back to the check. Have I finished this already? Seems like it. Okay, so now with that I have this number. The only thing I miss is not number. Is not number. If it is not number, this will return false. Why it is true? What's going on? Okay, I think yeah, because of that. Right, so Copilot is nice, but don't trust it wholeheartedly. False. That's why I still need unit test. So true. And what the cat? I should add this over here, or it is down here. Yeah. But let's move it up here. I want to move those cases over here and then this case down here. So it is a little bit easier to read. Is number type. So this will be return false. False. Okay, removing that. Going back over here. This will now be true. Is not number. Yeah, the is number is not number is even worse. Should I really create a straight variance for this and the loose variant for the other case? It feels like I should do it like this, because if not, you know, when you're using it, this will be quite confusing. Return true for special case. What are you talking about? Okay, yes. False for special case, and then true should return true for all other type. This is true, and then this is not a number. Yes, it is not a number. Return false. Oh, no, it is a number, so it will return false, and then literal I can remove. Right, and then also this not a number, this is false, and this is true. Get a 0 in there, and then so this should be 1. So now these are all true. And then this true, this is false. Okay, so that looks good. That looks good. So that's the number type. I now have all 4. If I describe it over here, yes, I did. Remaining number type. Should I rename them to right? I don't know. I could. Maybe I should. Okay, so the number is taken care of. Boolean is there. String. String, yes, is already there. And then symbol and big int. Symbol. I think that would be almost the function already have it. Array already have it. Triple. Yep, triple have the type but have not added the test yet. And so since we have already streamed for close to 1.5 hours, so let's take a break and then we will come back and continue. And maybe I should also just stop the stream right now to create another one. Well, actually, no. Let's just take a break. Let me finish this so that yeah, it's more focused in terms of the topics. So let's take a break for like 5 minutes, and then we will be back. All right, I'm back, and let's keep going and really try to finish this. Okay, so we go through the string. Well, that's the symbol, but actually before the symbol, we have the tuple type. Tuple type is already there. However, the test is not complete. So I have the description, and also the description needs some cleaning up. So if the tuple type, this is a tuple, and not an array. Just make sure that it is pointed out that way. All right, so that's, and then this is incorrect. So this should be that, this should be never, and then is, and not an array. Oh, it's not a triple. It's not a triple. It doesn't care in that case it is an array or not. So sort it out like this. This will be never, and then this will be number array, and this will be string. Never, unknown. Just add them over here. Alright, never, still never. This is always a little bit weird, but it's understandable. It's okay. Never. This would be never. Okay. That's that. Did I describe it correctly? It's not a tuple, right? So these are the true case. Okay. So that is a tuple and not an array. Want to make sure that that is spelled out. Also, let me just add those in. Nope. Pause. Is tuple. It's not a tuple. So that's right. Right, so this will be false. Let's copy this over here. Doing it like this, and then this is not tuple. So now that looks fine. And then also I'm going to rename this tuple to tuple type, because the thing is under this tuple folder, right? This is just for the type checking. There could be other functions, other types related to tuple, and since adding the comments take up a lot of space, so I don't want the file to be too long, so let's have them separated. So now here let's double check the test here. Right, so this on the left hand side it is the newer structure or conventions that I have. So is return t is a tuple. Right, so tuple type. So empty, I will always want to check the empty case. this will be true, and let's say just that should be sufficient. And then I want to call out the other case. Right, that's why I have them separate. If T is an array. Alright, so this will be triple type, and then what's passing in is an array. Say, for example, string array. This will be never. Okay. I think that would be it. And then for the special type, also put this over here. This will be never. Do I already have that over here? No, I don't. So separate this, and then here let me put a string array. Make sure that this is also that, although you know the code wise is very straightforward, but for the test I want to be as liberate as possible. Never, it returns never, returns never, it returns never. Okay, for other types, don't really need the word or. And so Boolean, true, false. Where is number? Number, well, let's do a 1. Actually, the begin I also can use a literal 1n. Does that. Let's also add this in over here, 1n. Although it's really optional, just for completeness, because we know how the code is implemented and it's get pretty stable now. So that's that. And return never if there's an array. That is the test I have here. Just moved it up there. Return TT if it is triple. So this is the same thing, right? But putting it up there make it a little bit easier to read. And then we have this the union case and the intersection case. So triple type, if it is a union, so say that, and union ish, it would be Boolean. What does it return? It would be for the other case, except option, except function, I should say, we are this should be never. Return never for union type, because it is not, because we are doing a strict case. This really should be never, but it does not. So I think we found a bug over here. Union of triple and other type. Right, this really should be a it should return never for the same logic. There's no number literal. Well, let's check triple type, different length of triple. Right, so that I feel like that should return true, and it should be doing this. This is correct. this is correct while this is not. Is my logic sound here? Is my logic sound here? I think it is sound. So now let's see why. What is the problem? My guess is okay. Any or never. Oh, here. What I got is got the pass through. I got the then case over here. This checked one way. This got spread. It got spread. What should it be? How should I do it? It's making this line is making sure that it is not an array, which will check this guy. This guy, it got distributed out. Infer a you really should go to the else case. We know that when it is string, it goes to never. When it is a literal, this got passed through. Why is that? For sure, we don't have to worry about this. I'm 100% sure about that, right? And so the question is this. You return it. The string. Oh. Oh my God. Oh my God. Well. Oh my God. Because string also have this. So string also extend array. Type R equals to string extends array of any 1 or 2. You return false. Why did you get there? Hey, go to false. That shouldn't be right. What's going on over here? So this I got 1 for sure. Yes. Right. So T extends let's say just any array first, 1, 2. So over here, I already get 1 or 2, right? Which is correct, right? So if I say this, the question is, if I say this is T, right, then I get that. So the string is still going to the false case, which is what I expected, supposedly. This actually, I think it is not necessary. So let's see. So number extends the length. Let's say 3 or 4. So I got 2, which is from the string. And then I got 4 because of the triple. This is correct. Right, so if I say this is else, this is else. Right, I got 4. And then if I say this is then. Oh, I get it passed through. What the? This should be T. There you go. Holy cow. Then this won't work. So the T over here is narrowed. So we were able to strip out from the union type to only, it does the filter, it distribute and filter like this. And then get that T that we want. So the question, no, the question is, what does it mean by filter, right? We have to step back a little bit. What does it mean by filter? Does it filter and process the distributions? Or it's just do a top level check and say that if it is contain other type, it should return never. Because there are two issues that we have to solve over here. One is this question, right? Should I filter it down distributedly? And the number 2 is, how do I handle this case then? Right, so the construct over here is using this then. Well, yes, okay, so one way to do that is doing this. If that is what we want. Yes, so that will solve one of the problem. So now is the conceptual problem. So what are these types wanted to do when it comes to union? Should it break down the unions and pick out, namely filter, only the one that we want, or it checked the type as a whole? I actually don't know. Don't know what should it do. I really don't know what should it do. However, well, what I got over here, I got some other error. So this, I get 2. Why do I get 2? Why does it fail here? The other case, this is working. It go to some weird never case. Say this one is still correct, but this one, somehow get to an else case. My guess is over here. Nope. It get over here. It does not. The then, which is T, does not but hello? What? Oh my god. Oh my god, I think this is a bug. This is a bug in TypeScript. I think this is a bug in TypeScript. Shit. Then what should I do? So if I'm doing this, this will fail because the then does not extend. I get over here. You got who over here? Yeah. What do I get in this then over here? Then is, oh, I override it. No, it's not a TypeScript error. This I override it. Shh. That's not good. Yeah, I override it. So this become 1. Of course, 1 is not an array, so that it goes to this case. Holy mo. So, well, that kind of help in terms of determining what the behavior should be. because then that means this is simply not possible as long as I am doing this kind of override, right? Of course, another way is to say, oh, let's not do all these overrides, and depends on the extents and all the stuff, right? That's definitely one way to do it, and but then that really depends on how the library and the types are defined. What are the use cases. So, I think it probably makes sense to have different types, for the different behavior. It really depends on how you want to use it. It really depends. So, in this case, so meaning, I would need to say this would return T if or is an union, but this really just contradicts what I said about the function containing at least one tuple. This is the behavior that this current type have. Right, and I really actually don't need that. This is fine. So this will be equal to that case. Right. Then returns never if E is an union of tuple with with non-tuple types. Right, so this is another behavior that we might want, and then we can get that to a different type. Right, so this is saying that this this should be a new type that act on the filter within the union. Right, so that is the behavior for the other thing, the other one, if we need to do that. That type cannot support override. Actually, so let's say, yeah, that's one of the problem with the to-do in Jest. I really wish that it allows us to change this to to-do, because even with to-do, it makes sense to have some we can have some implementation, some thing about the type, but currently still the for the Jest, the to-do does not allow you to have a callback. So I have to change this to a skip. So type tuple type filter union. let me copy this over here. B equals that, and then let me add this in. I can export it, doesn't really matter, it's during the test. So in this case, it's filter, then we cannot have the filter. So the else case will be never, this else case will be never, and then this will be T, right? So the T is drilled down, right? Because the then type can be overridden, and the logic will not be correct. Right, like that. And then this will be never. I guess. Oh no. Yeah, it will be filter equal to the this will return filtered union if T is a union type of non-union type. So meaning if I have two of them, right, 1, 2, then this should still have that. There you go. Right, it will be like that. This will be pretty useful, right? I can imagine that this could be pretty useful, but unfortunately then I have to break this pattern. Right? And this pattern, as you can see in the equal type, this make the code a lot more compact and easy to read and write. So it have its drawback, but you know, it's really just a pros and cons. And I would tend to keep both if needed, instead of just forcefully, oh, let's say this doesn't work and let's take it out. I don't know. Maybe it could go either way. All right, so now the problem is this. If this is the behavior, then what is the behavior on, say, the function type? Okay, this is still the same. Right, this is what we want. The only thing is the other thing. Those well, undefined type spec over here. This get the union. Return never. Return. Oh no. What? Well, the union, the undefined type, this haven't been cleaned up yet. So if T is undefined, have the equal, and then this will be this returning undefined true. Right, so let me add this in true. So this undefined, if it is undefined, there's no other case written for other special types. For special types, All right, so these never or other types. The undefined is there, the number is here, the literal is here, Boolean symbol back in. Let's also add the one n over here. And then return the, this will return never. This is a problem, right? So this and this does not match. Because I need to make sure that they are, you know, consistent. Right, so this really should be undefined or 1, right, which is a completely valid type. This will be true. And then let's just do a 0 will be false. And all this will be false. Any unknown, never, and void. So now the problem is this. Right now, this return never. It's very likely is because of here. And this it was checking. Well, primitive type, this would, how should I do it? This does return false. And this does return false. What should I do? What should I do? Seems like I will get stuck here for a moment, or for a while. Need to think about how to handle the union types in this case. Right, so for the tuple, I was checking it like this. I'm not using the tuple mechanism to do the same thing. So the bottom line is these two behavior, which and this one returning the never, which one is the correct expectation for this set of types? And right now, I don't think I have an answer to that. I need to think deep into it to see what is the right thing. So, well, with that, I don't think I will be able to come up with a solution right now during this stream. So let's end the stream over here, and hopefully this is interesting to you, and you can see that when you're doing the type level programming. And in fact, this is really have not much to do. The problem that we're facing has not much to do with type level programming. It's really just basic programming mechanism or practice. Is that while you write something and it have certain behavior, is that behavior what you want, right? What's your objective, right? And sometimes, when it gets to the detail, it's not that clear. We really need to drill down and figure out this what you want for specific code that you're writing, right? And again, it can go either way, depends on the use case, and they can be two separate types. So the question is, the one that you're working right now, which way do you want? And so it also shows you that you really need to test to figure this out, because you can see that throughout the stream, right, for the other types, and just streaming, going through it with no problem until we hit here, right? Then it brings up the question, and now once I decide which one to go, if I need to go for the right hand side, then I need to go back to the all other types to make sure that they behave the same, because if not, it will be confusing. So yep, that's programming. Welcome to the programming world, or the open source world, or set yourself with a higher standard, whatever that is. And with that, that's it for this stream, and hope you like it, hope you enjoy, and hope you learn something, and we will see you in the next one. Bye bye.